In the name of God, the most gracious, the most merciful, peace be upon you and God's blessings. We will have a look at practice problem number 522 from the Steel Design Handbook. There is an unsymmetrical flexure member consisting of 3 bars. The upper flange is 12 inches by 0.5 inches. The web part is 3/8 inches by 16 inches. The lower flange is 7 inches by 1/2 inches. There are 3 requirements, A, B, and C. For part A, it is required to find the Y bar, or the distance from the top of the upper flange to the plastic neutral axis. Due to no symmetry, the plastic neutral axis does not pass through the middle. First, we will estimate the total area of the 3 bars. The area of the upper flange equals 12 by 1/2. The area of the web equals 16 multiplied by 3/8. And finally, the area of the lower flange equals 7 by 1/2. The total area is equal to 15.50 inches square. For the half of the total area is equal to 7.75 inch square. In the next slide, since the area of the top flange is less than A total over 2, the plastic neutral axis cannot cross the upper flange, so it will be located below the upper flange by a distance. Let us assume that this distance is y sub 1. We can find y1 value by equating the difference between A total over 2 minus the upper flange area by the product of 3/8 y1. The value of y1 is equal to 4.667 inches. In the third slide, we will estimate the y bar distance, which is the distance from the top of the upper flange to the plastic neutral axis. We add 1/2 inches to y1. We will have y bar equal to 5.166 inches, which is approximated to 5.17 inches. We could check the area below the plastic neutral axis to make sure it is equal to A total over 2. The area of the half web is equal to 3/8 by 11.333, and the area of the lower flange is 7 by 1/2. Adding the two areas together, we will find that the total area over 2 equals 7.75 inches square. That was the requirement A. From the next slide, as required by item B, we need to find the plastic moment in case of A572 steel grade 50 is used. The yield stress F sub y equals 50 ksi. We will estimate the compression force C, which equals to the A total over 2 by F sub y equals 7.75 multiplied by 50 equals 387.50 kips. In the fifth slide, we will estimate the C1 distance, which is the distance from the point of application of force C to the plastic neutral axis. The value of C1 can be estimated by taking the first moment of area for the upper half of the section about the plastic neutral axis. The moment of area equals 33.609 inch cube. We divide the first moment of area by A total over 2, we can find the value of C1 as equal to 4.34 inches. We move to the next slide to estimate the distance T1, which is the distance from the point of application of force T to the plastic neutral axis. We expect to have a different value compared to C1 since we do not have symmetry. Again, we will estimate the moment of area of the lower half of the section, which is the sum of the moment of area of the lower flange and the web area part below the plastic neutral axis. The value of G1 equals 8.34 inches. In the next slide, we have C, T, the forces values, and C1, G1, the two distances. The plastic moment M sub B is equal to C multiplied by C1 plus G1, or C multiplied by YCT, which is the distance between the compression force C and the tension force T. The M plastic value equals 387.5 multiplied by 12.68. We divide by 12 to find the value of MB in foot kips. The M sub B value is equal to 409.46 foot kips. This is a requirement by item B. For part C, it is required to have the value of the plastic section modulus about the minor axis Y. Due to symmetry about the axis Y, we will deal with the C-shape section and find the first moment of area about the Y-axis and divide by the sum of the three shapes. We will find that X bar equals 1.592 inches. Finally, we will estimate M sub Y, which is C multiplied by 2 X bar, and then divide by F sub Y. The final value of Z sub Y is equal to 24.676 inch cubed. Thanks a lot and see you in the next video. God bless you all.